So far, we have learned that in mathematics, a term is one number or a group of numbers in a particular number operation regarded as one number. In carrying out number operations, further number operations in algebra, through experience, we have come to know that there are some number operations in algebra we can't proceed with. And sometimes there are ones we can proceed with, and at the end we get the answer or the result. What makes it possible for us to proceed to the final answer to an algebraic operation? And what makes it impossible for us to proceed to the last stage? So far, we have seen that there are concepts known as like terms and unlike terms. So I ask, what are like terms? What are unlike terms? So that if we learn them, we can tell how to use them to carry out successfully number operations in algebra. That takes us to the fifth lesson objective, and that is like terms and unlike terms. In it, I will define like term and define unlike terms, and then guide the way into recognizing or identifying like terms when we see them. Please follow through as I do that. Having learned the concept of terms, let us now focus attention on this objective of number 5, and that is like terms and unlike terms. When do we say that mathematical terms are like terms? When do we also say that they are unlike terms? Let me use these two sets of numbers to explain the concepts of like terms and unlike terms. Already, as you can see on the screen, it has been stated that 7xy and 2xy are like terms, and that 7xy and 2x squared y are unlike terms. Now, I want to ask, why is it that these two are considered like terms and these two are considered unlike terms? What exactly are like terms and what are unlike terms? Together, let us make observations so that from these observations we come to learn the meanings of like terms and unlike terms. To start with, consider 7xy and 2xy again. In 7xy, we can take it that 7, being a constant, is a coefficient of xy, meaning 7 is telling us how many xy's that we have. And in second case, 2 is telling us how many xy's that we have. So 7 is quantifying or counting xy, and 2 is quantifying the same xy. What it means is that both 7 and 2 are quantifying the same thing. Both 7 and 2, which are different coefficients, are counting the same thing, the same xy. Look at this second case here. 7 and 2 remain the same constants. That does not mean at all times that coefficients must always be constants. But in most cases, we use constants to find out which algebraic expressions are like terms and which ones are unlike terms. Let's continue. 7 and 2 are still the coefficients of the algebraic expressions found in both number expressions. Xy is what 7x is counting, but x to the power 2y is what 2 is counting. 7 and 2 are counting the same thing in this first case, but 7 and 2 are counting different things in second instance. Already, the meanings of like terms and unlike terms are emerging. It is based on that we refer to the first set of number expressions as being like terms and second set as being unlike terms. Then we ask, what is the definition of like terms? In plain terms, what are like terms and what are unlike terms? Based on these observations, please let us look forward to definition or to seeing the definition of like terms and unlike terms. Please watch out. First, let us take the definition of like terms. We have two different definitions. Both of them are saying the same thing, but different words are used to send a message. If you don't understand the first one, you are supposed to understand the second one. The same message is passed. Like terms are separate number expressions in which the same thing or number is being quantified. If you reflect on the keywords used in this definition, you can already begin to link this statement and its meaning with our prevailing cases. Or, like terms are terms that contain the same county to the same power. I believe that you remember what county is. County is that which is being counted, and coefficient is that is counting. Do you also understand this one? Perhaps you understood both of them, but I believe that this second definition is simpler. Alright, that is one statement, that is one word or one expression in this second definition that should matter to us. What is it? Look at this second one, second set of numbers, 7xy and 2x squared y. Why is it that this and this are not like terms? First, why is it that this and this are like terms? Let us confirm it in the light of these two definitions. Like terms are separate number expressions. Obviously, 7xy and 2xy are separate number expressions that should possess what quality? In which the same thing or number is being quantified. Remember that counters or coefficients count. They count either things or numbers. A number can count a thing, a number can count a number. That we learned before now. In most cases, we see numbers counting numbers. In algebra, we don't have much interest in numbers counting items. Instead, we have interest in numbers counting numbers. So 7 is counting this product of xy, and 2 is counting the same xy. So that means the same number xy is being counted by both 7 and 2. Based on that, xy, the same xy is being quantified in the two separate number expressions. Based on that, these two expressions are called like terms. Is that clear to you? Even before now, you could have gotten the sense of it. Now compare it with this second one, 7x and 2x squared y. They are unlike terms. Let us again find out why they are unlike terms in the light of these two definitions. If you watch the first definition, you say they are separate number expressions. Surely this and this are separate number expressions. If they qualify to be called separate number expressions, but they fail to qualify in the light of the remaining properties that they should possess, are we still going to be correct to call them like terms? No. If two properties are said to be what qualify something to be what it is, and that has one of those properties, are we going to be right to go ahead and say that that thing is qualifies to be called that? No. In this case, two things are involved. Yes, that 7xy and these two xy's, x squared y, are separate number expressions. But is it correct to say that both 7 and 2 are quantifying the same thing, the same number? Xy is what is what 7 is quantifying here. X squared y is what 2 is quantifying. This might be misleading. That you see x here and you see x here, you see y here and you see y here, is a temptation. You might be tempted to think that two of them are like terms since the same variables are there. In some quarters, like terms are defined as terms that contain the same variables. If that definition is accepted, anyway, to an extent, it is true, but the challenge there is that this x and y are variables, and the x and y are also variables, which means that the same variables are found in both of them. But at the same time, we say that these two are not like terms. The implication is that something is remaining in that definition. This second definition brings that to limelight. It says like terms are terms that contain the same county to the same power. It means that the variables, if you have variables that are being counted, must possess the same power. For instance, this x is to power 1, this y is to power 1, although not written. This x is to power 2, and y is to power 1. Therefore, though they contain the same set of variables, the variables are not exactly the same power. Therefore, though they are separate number expressions, they contain the same variables in different powers. Being in different powers is what disqualifies the two of them from being like terms. Be very careful next time if you see the same set of variables. Before you rush into a conclusion that they are like terms, watch the powers of those variables. Based on that argument and reality, we conclude that 7xy and 2x squared y are unlike terms. That takes us to the definition of unlike terms. Already, what you expect is going to be opposite of these definitions. Just a few touches and the definition of unlike terms emerge. Let us see the definition of unlike terms. And here comes the definition of unlike terms. Unlike terms are separate number expressions in which different things or numbers are being quantified. It's just the opposite of the definition of like terms. Or, unlike terms are terms that contain countees which differ in symbol or power or both. Which means that from this second definition, the countees might differ in symbol. For example, one may carry x, the other one may carry y. That way, they are unlike terms because they differ in symbol. They might have the same symbol, but they differ in power. That means the only difference is that they have different powers, as in the case of this second set of numbers. It is also possible that two terms are unlike terms because they differ both in symbol and in power. Therefore, this definition, second one, appears to send more specific message. Let us see some examples selected to help us see how to identify like terms and unlike terms. And here comes some examples selected for that purpose. We'll have about 6 of them. The first is 2y to power 2 and 5y to power 2. These are separate number operations or number expressions. Are they like terms or unlike terms? I hope you remember how to find out if two separate terms or more are like terms or not. 1. They must have the same county. 2. and 5 are counters. While y to the power 2 and y to the power 2 are the countees. And what is more, the countees must have the same power. This y here and the y here, do they have the same power? The answer is yes. Therefore, 2y to the power 2 and 5y to the power 2 are like terms. I hope that is clear. Next, 2y to the power 2 and minus 5y to the power 2. If you watch the first and second, you discover that there is just one small difference. That small difference is written to help us see another kind of lesson we can learn from the concept of like terms and unlike terms. What lesson is that? The lesson is that the direction of the expressions does not determine whether the expressions are going to be like terms or not. This is plus 2y to the power 2 and this is minus 5y to the power 2. That this is plus and this is sign will not be a factor as to whether the two expressions are like terms or not. Only two things determine. What are they? The type of symbol being quantified, if any, and the power of the symbols. The symbols must be the same, and the symbols must have the same power, irrespective of whether they are minus or plus. So based on that, we also conclude that 2y to the power 2 and minus 5y to the power 2 are like terms. What about this number 3, 2u and 3v? Are they like terms or unlike terms? What are you thinking? First, what is being quantified in this first one? It is u. What is being quantified in this? It is v. So 2 and 3, which are quantifying, are they quantifying the same thing or different things? Obviously, the things being quantified differ in symbol. The very first obvious reason why we should not call these two like terms is that they have begun to differ from the beginning. To differ in symbol is more obvious than to differ in power. Here, the two of them already differ in symbol. Therefore, outright, we conclude that these 2u and 3v are unlike terms. What about the number 4, 7, and 2? Are they like terms? Remember, in that definition we said separate number expressions in which the same thing is being quantified. In this case, 7 and 2 are quantifying nothing, but we still call them like terms. Why? 7 is quantifying something, and 2 is also quantifying something. What is that 7 is quantifying? 7 ones, because 7 times 1 is still 1, and 2 times 1 is still 1. So 7 is quantifying 1, and 2 is also quantifying 1. Therefore, what 7 is quantifying is what 2 is quantifying. Sometimes in some quarters, people say that this 7 and this 2, for instance, are quantifying nothing. If they are quantifying nothing, it means that it is 0 that is supposed to come in the bracket after 7 and after 2. And 7 times 0 is nothing. And it is not going to give us this same 7 we have here. So the best thing to say is that this 7 is quantifying 1 and this 2 is quantifying 1. Recall that 7 means 7 bracket 1, which means 7 times 1. That means 7 is quantifying 1, and 2 means 2 bracket 1, and 2 bracket 1 means 2 times 1. That means that 2 is quantifying 1 also. 7 quantifying 1 and 2 quantifying 1 make it possible for us to call these 7 and 2 like terms. Therefore, we conclude from that standpoint that 7 and 2 are like terms. Number 5 has 7x and 2 as a set of numbers to be compared. 7x. In 7x, 7 is quantifying x, and in 2 is quantifying 1. What 7 is quantifying and what 2 is quantifying are not the same. Certainly, therefore, we conclude that these two are unlike terms. They are not like terms. Okay, the last one is 5xy and 2y. In some places, people conclude that as long as there is something common to both expressions, that the two could be called like terms. That's not correct. Granted, we can call these two similar terms, but not like terms. There is a clear difference between similar terms and like terms. In similar terms, you see just one or two similarities between them, but not everything in the first expression is in the second expression. They might have only one or two things in common, but not every variable in common. That way we call them similar terms. But when the same set of variables, if any, is being counted by both number expressions. So at this point, we discover that 5 is counting xy and 2 is counting y alone. What it means is that the coefficients or the counters are counting different things. 5 is counting xy and 2 is counting y. Based on that, the two are unlike terms. Please watch as the status of each of these sets of numbers is appended by the side. And here they come. The first set is like 10, second set like 10, third set unlike 10, fourth set like 10, fifth set unlike 10, and then the sixth set unlike 10s. The time has come for you to test if you're following what I've been saying from the start of this section. Please watch out for an exercise. And here comes the checkpoint. Says determine, hence state if the following sets of expressions are like terms or unlike terms. Number 1, minus 3x and 5x to the power 2. Number 2, 5uv and minus uv. 3, u squared v and uv squared. Number 4, 12 and minus 20. Number 5, 4xy and 7xb. Number 6, 8cx and minus 11cx. Number 7, 10cx and minus 6gy. Number 8, minus x and x.